First off, my name is Ben Smith. I'm a software engineer on the WebAssembly team at Google. And this talk is very much meant to be sort of a follow-on to what Thomas talked about. So I called it WebAssembly 201, Porting Software to WebAssembly. So Thomas sort of got you into the mode of thinking about, like, how would you write WebAssembly code using emscripten? And I'm going to do a little bit more. But first, I want to take you back to 2010. Back in 2010, you may have heard this. Let's see if it actually works. So this sounds probably a little bit different than the Justin Bieber that you're used to, because it's slowed down 800%. A person named Nick Pitzinger made a version of this, and the internet kind of went nuts for it. Like, this YouTube video has 3 million views. That's not a lot. That's Justin. And everyone's like, wow, it's like Justin in a choir. You know, it's really pretty amazing. So people kind of went nuts for this. You can sort of see, let's see, there we go. Lots of news articles, people saying stuff like, if you slow down Justin Bieber by 100%, you get art. And Justin Bieber is amazing when he slowed down to 80%. And what they found was there was actually one tool that was kind of behind this all. It's a tool called Paul Stretch by this person named Paul Naska. So they, NPR actually went and talked to them, talked to this person, and said, like, well, how does it work? What is it? And it's like, oh, it's actually a pretty simple piece of software. I wrote it in 2006. Part of, like, my, I wanted to be able to do audio processing and so on. And then it wasn't until 2010 that people actually found it and played around with it and really found that they liked it. So this is the link. It's a SourceForge page. Remember those? Remember, this is 2006, back when the news was a little bit slower. And this is kind of how it works. So the idea is that you take this audio file, and what you're sort of looking at here is sort of the wave format, and it sort of takes these chunks of audio randomly, and then it spreads them out. And so what's amazing about this is that you can actually slow down audio from 8x to 10,000x. In fact, there was a story about one band that was like, well, we're going to release our album in a year, and we're just going to put up a live stream playing at 40,000x, and eventually it will finish, and then we'll release the album. That's what they did. So this is a really, really cool piece of software. I thought, like, what am I going to do for this talk? I had no idea, and literally 2 weeks ago, I was like, oh, let's see if I could port this. So this talk will mostly be my porting tips. In the future, if you want to follow me on Twitter, I had it up at the beginning, I will write up a little blog post with a lot more details, but for now you can basically just, dig in and listen to a few of these tips. So, tip number 1, build normally first. It seems obvious, right? A lot of these tips will seem obvious, but this is like me porting a lot of code. One of the first things that people do is like, oh, I'll just try and compile it with my fancy new emscripten compiler, see what works, see what breaks. No. Build it normally first. So here's the step that I did first. Pull down the library, Paul Naska / Paul Stretch, using Git, get this nice Git output, and then I install all the dependencies. So you can see quite a few dependencies here. And you also see that there's a command to actually compile this normally. So this is really, really important to do. The reason that it's important is that you learn a couple of things about compiling normally. What you learn is, look at all these libraries that I needed. libaudiophile, libvorbis, libfltk, portaudio, libmad, libmxml. These are all things that maybe, or maybe not, I will need to port to make this project work. Okay. What I'll also learn is, oh, actually, when I compile the code, I know that it actually compiles. I know that it actually runs, I got something that I could play around with, so great. Step 2, for C++, use emscripten. Now, Thomas talked a little bit about this. There's lots of other compilers for WebAssembly. One of the big benefits of WebAssembly is that you can use many different languages. The next talk, we'll talk a little bit about using Rust. But for C++, emscripten is definitely the way you want to go. Use emscripten for that. So, Thomas mentioned this as well. emscripten.org. Super easy. Just download it, pull it up. It'll give you a compiler that you need. This is what that page looks a little bit like. It's got a lot of great information, API references for a lot of the tools that emscripten includes. So emscripten is meant to be giving you a lot of functionality like SDL or WebGL built in, like timers built in. So it's more than just a compiler. Like if you know C++ compilers, a lot of times you think, oh, well, it's just going to give you the basics, right? Input, output, prints, things like that. No, this gives you a lot of stuff built in. So emscripten is really great for this kind of thing. So when I download emscripten, the first thing that I do is just test a really simple project. So all I did here is create a completely empty C file, run em++, that's the compiler. This is exactly the same command. We didn't share notes. This is just what I did. And then just make sure that it actually gets you something. So here you can see empty.js. The date is wrong. Remember that date, everyone. That's a pretty important date coming up. OK, moving along. So tip 3, only port what you need. So remember before, we had a huge list of libraries. We had audiophile, libvorbis. Everybody know ogvorbis, probably? Yeah. MP3, all these files. We could port them. Well, you're laughing? You're like, Vorbis, of course. Vorbis of Corbis. So what I do when I'm porting something like an application, when you're porting a library, a lot of times you can just port it straight. When you're porting an application, often what I do is I try and see which parts of the application do I need, right? Because a lot of what this application has is like code for generating GUI interfaces and things like that. I don't really want that because the web gives me my own GUI interface. What I want to do is try and find the parts that are important for what I'm trying to do and then cut out the parts that I don't need. So what you can see here is the entire contents of the repo. And the things that I've bolded here are the things that I sort of just looked at and I went like, okay, well, what sounds like what I want? You know, I saw, oh, control, okay, maybe. Free edit, no, that doesn't sound right. Player, okay, that sounds interesting. Process stretch, well, obviously I'm stretching out audio. That sounds about right. Okay, stretch. So this is kind of what I looked at. And actually, when I first started porting this, I started with process stretch. I was like, oh, that's got to be it. And then I looked at it and I was like, actually, maybe not. So you'll end up having to sort of dig a little bit into the code. That's all right. So, but when I pulled up player, what I found is a lot of functions that do exactly what I wanted. Start, play, stop, pause, things like that. I was like, OK, this looks good. Player is what I want, right? All right, step 4. Let the compiler help you, right? When you're compiling code, when you're writing JavaScript, I assume a lot of people in this room write JavaScript. When you write JavaScript and you're not using a compiler, something like TypeScript, you kind of don't know if your code is going to work until you run it. But when you write C++ code, well, you also don't necessarily know if it's going to work until you run it. But there's at least the compiler that's going to help you out along the way. It's going to say, OK, well, you did this wrong, for one. You know? So let the compiler help. So the very first thing I did, actually, was I just took the compiler and I said, try and compile player.cpp. I didn't think that this was going to work, but I knew the compiler was going to tell me why it didn't work, right? So it tells me something right away. libmxml file not found, or the header file. That's what .h means there. So it gives me a pretty easy error to tell. And actually, I remember, because I built normally, mxml. That was one of the libraries that I needed. So at this point, you can kind of decide, OK, well, am I going to try and compile this library, or am I going to try and cut it out? You could go either way. What I decided to do was actually just pull down the library. I thought, OK, this library, it sounds like XML. It's probably not using any OS features. I can probably compile it myself. So I pulled down the repo, just like the other one. I ran emconfigure. That's another emscripten tool. You just run that, and it does the configure step for you. And then I run make. That's all I did. And it just worked. Cool, right? So it generates this library for me. That's what the .a is. It stands for archive. libmxml. So that was exactly what I needed, actually. So then I just go back, and these are sort of like magical commands they're not really that magical for C++, but like you may not have seen these before. You do -i, that gives you the include directory. You do -l, that gives you the library directory. And then you pass in lowercase -l, and that's the library you want to link. And I did that, and then I get a new error. And so then you sort of go through this process, right? You see which errors you get, and then you go, OK, well, how do I fix this error? So step 5, tip 5, do the simplest thing first. It's so easy to just like dive in, right? When you're writing code, you just go, OK, well, I'm just going to like, oh, man, what am I going to do? I'm just going to start working on these things. I always try and do the sort of minimal amount. So in this case, we saw before that there was this FFTW. That was the next header. So I was trying to decide, OK, do I try and compile it like I did with MXML, or do I try something else? So when I looked at the repo for Stretch, I found, OK, it actually supports 2 different FFT libraries. So the FFT is kind of what you saw before. It's a mathematical function. Math majors in the room here probably did a lot of FFTs by, probably not by hand, but you probably remember Fourier transforms. So there's FFTW, is a great library, super fast, super complicated. There's also this KISS FFT. KISS stands for Keep It Simple Stupid. I was like, which one do I do? Simple, 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 small. It's already included in the repo. So I did that. And these commands look kind of magical as well, but actually they were all there for me in the compile script for me when I compiled normally. So I actually just copied these and put them in. So you'll see a few things that are a little bit weird. There's this -xc here that says compile this file in C mode rather than the C++ mode. And then xC++ means go back to C++ mode. That's all it is. And then you can see I do this -o just like Thomas did in his talk. And then I get past it. Oh, look at that, making progress. So now I get to this audio file .h, not found. That was the one we saw before, right? So along the lines of keeping it simple, I looked at this header file, and I saw some things here. So what I found was it includes all of these different audio file formats. That's what the A input is. That's what the Vorbis input is. That's what the MP3 input is. Rather than actually porting these, I actually thought, well, you know what? Let's do something even simpler. These are all actually an interface. They all follow the same interface. I can just implement my own dummy interface. So what I did was I made my own dummy input in the header file. And then in the C++ file, I found the exact same code. See where it's creating Vorbis MP3 audio? And I just said, don't do that. I do this #if. That's in C++. You can basically say, if I'm compiling for emscripten, then do this. Otherwise, do something else. So I create my own dummy input. Simple. Very, very simple change. Like, this is the first change that I actually made to the code. And then you can see this interface, input S. This is the way you would do like a C++ style interface. I just create my own dummy interface. And you can see this is like all the code that I did. Return false, return 0, and then for close and seek, do nothing. Right? All that I'm doing here is saying, do the simplest thing. Do nothing. I just want to try and get it to compile. And ta-da, it compiles. Awesome, right? So I'm ready to roll. I got my program working. Well, not exactly, actually. The problem is that, as Thomas was showing, WebAssembly kind of needs you to sort of tell you, well, what do you want to be able to do with this code, right? So I have my WebAssembly module, but it can't export it doesn't export anything to JavaScript yet. So actually, I have basically a useless module. But what I've done is I've gotten it so that my C++ code actually compiles. And so now I feel more confident. I'm like, OK, let's take this piece by piece. So here's my tip that's a little bit different than what Thomas talked about. And that's using this library called embind. So what's really cool about embind, it's built into emscripten. So it allows you to basically bind JavaScript to C++ in a much, much, much more natural way. You can take C++ code, C++ classes, functions, everything like that, and bind it directly and have it create the exact same JavaScript code. So this is the embind documentation. You can find it on emscripten.org as well. There's all the links for these things I'll have at the end, so you don't need to try and guess where they're at. And this is sort of like my sort of intro to the binding, right? So what I did was I just write the bare minimum here. You can see that I've got this player class. That was the same player class we saw before. And then I have this start play function. That's the same start play we had before, and stop and pause. And you can see there's not much going on here. Really, all I'm saying is I've got this name that I want to assign to JavaScript, and here's the C++ code to go along with it. That's really all that's happening here. Now, by the end, I had a lot more classes than this, but this is kind of where I started. And then you can take this and run -- bind that says use embind for me, and then I pass in some of the other CPP files. What I found was that as I started to compile the code, it would give me errors. It would say, oh, well, this doesn't work, this doesn't work. And so I started including more CPP files, the same ones that the native code was compiling, and eventually it compiles. And now I actually have something, right? The thing that I'm missing, though, is that I still have my dummy implementation of the audio. So this point, I am probably the most excited about. Web APIs are powerful. This is the thing that's so cool to me, is that there's a web API called decode audio data. It's built in. All the browsers that you use have it, right? And what's amazing about this is that I don't have to compile MP3. I don't have to compile OGG for WASM. I don't have to compile any of these audio file formats. They're all built into your browser, right? So I thought to myself, OK, well, rather than compiling these into the WebAssembly module, why not just leverage the fact that the browser already has it? So what I did was, rather than taking the MP3 files and compiling those, I created a little wrapper, a little JavaScript input wrapper class. And that's what I'm doing here. So you can kind of see the same sort of structure as what we saw before. There's this open, close, read, and seek. And then you can see I'm mapping the strings as well. You know, the format is like, OK, maybe you have to sort of try and figure it out. But the docs all tell you how this works. Basically, all you're saying is, when I call this C++ function, call this JavaScript function. Just passing it straight through. This one right here is a little bit more special, right? So when you're doing a read, what you're actually saying is, take this. So if you don't know C++, this might be a little bit confusing. But basically what's happening is you're saying, I have a certain number of samples, audio samples, and I have a data pointer that points to that range of audio samples. And what I want to do is convert that into something that the JavaScript engine can actually use, because it can't use pointers from C++. So what I'm doing here is I'm saying, well, take that range of memory and actually convert it to a typed array. So that's all that's happening here. The ×2 is also a little bit tricky, but that's all that's doing is it's saying, actually, there's 2 channels of audio, so you need to have a twice as long buffer. That's all that's doing. And then in the binding layer, I do basically the same sort of wrapping as before, but now I'm wrapping it for input S. So input S is our pure virtual abstract base class. And so I just map all those function names straight through. And again, read is a little bit special because I want to create my own interface for it. But otherwise, for a lot of functions, you can pass them straight through. And then finally, in JavaScript code, I can actually derive from this base class and create my own JavaScript base class. And now what's really great about this is that any time the WASM module, the WebAssembly module, asks for audio, it'll actually come out to JavaScript, and I can put anything I want in there. I could put a sine wave that I generated programmatically, or I could put audio that I had decoded from decode audio data. And so just to give you sort of a high-level idea of like what's happening there, essentially I have this read function, and it's got a pointer to that data. It just wraps it. It just exposes that and wraps it into JavaScript and gives me back a uint16 array. Now, this is something you maybe haven't seen a lot of if you write JavaScript, because it's a little specialized. But essentially, all it's saying is that it's a very specific type of array. It's an array that only has uint16 values, which are values from 0 to 65,535. So that's all that's happening here. That's all that I had to do. And actually, when I did that, it was done. Like, my code was, like, I was able to generate audio. And to show it to you, I actually have some fun little demos. So let's see if I can if I know how to use a Mac. All right. Yeah, what is it, Command++? There we go. Yes. All right. So I have some demos here. And I'm going to start just playing this one. All right. OK. Obviously, not slowed down. Demo fail number 1. Let's see if I reset it, if it works properly. There we go. So the thing that I think is so cool about this is that I didn't actually have to extract the audio at all. This is an MP4 file. And when I pass the MP4 file into decode audio data, it says, great, here's the audio track. And then I hook it up to the video tag element in the browser, and I just say, play at the same rate as the audio is playing. And now I can overlay those two pieces, and I get the ability to create a video that normally you would have to create using like audio or like using video editing tools. This is just in the browser. So I thought this was so cool. Thank you. I thought this was so cool that I went through and I did some other fun demos too. So if you'll indulge me. Like I said, I'm kind of an old guy, so these are All right, so for the young people in the room, that's Peter Gabriel, Sledgehammer. He's saying, you can have a steam train. That's why the steam train is. All right, so I thought this one just sounded really, really awesome. For people who don't know, this was a meme called Mr. Trollololo, I think. And I just want to hold for this one note because I think it sounds so great. Isn't that? I love that. Okay, and so then last demo, just something like kind of silly and fun. All right, so I apologize to everyone who's going to have that song stuck in their head for the rest of the night. I will actually cut it off here. Thank you. And actually, that's all I have. So if you want to know more about a bunch of this stuff, here's a bunch of links. I don't tell you what they are, so you can just check them out and see if they're cool. If not, then, I'm sorry. Thank you.